Hello, can you hear me?
Yes,
Yes. Yeah, how are you guys doing today? Um,
good. How are you?
Fine, thank
Good.
you. So today we focus on rounding up the concept of probability. Um, I'm going to share my screen with you. So we're going to round it up, starting by discussing what we call conditional probability. Okay, excuse me. All right. Make sure everybody's seeing this. Yeah, we completed by discussing cons conditional probability and doing some examples on that. Then I'll give you a class for the weekend. Actually, not for the weekend, due tomorrow, as a matter of fact. Now, the one I collected yesterday, remember, I'm gonna try and create them by this weekend. The one I asked you to watch the video and then write them out. So I'm gonna create it this weekend. And then this other one, I will explain more after the class is over today. Now, conditional probability is a type of probability that in real life, every almost I would say to me everything is conditional. Based on my experience, I want to pass the exam. The condition is that you study very hard and come to class, do all your assignments, and then take the exam and you pass. To get a job, first of all, you have to qualify for it. That's the condition. Yeah. I used to tell my students that even love is conditional too. Uh, that she say, okay, I love her because condition is that for young people, most people, as a matter of fact, oh, she's beautiful, so you fall in love for her. So I see the condition right there. Or maybe she loves you. Oh, he got money. You know, that's the condition. In any case, I think you get the point I'm trying to make here. That that conditional condition, we recognize it in statistics and we call it conditional probability. And that is our focus today, conditional probability. So the conditional probability of an event A, given that event B have already occurred. So it is the probability that event A have occurred will occur, given that event B will occur and has already occurred. So that a general explanation for the concept is that it measures the probability that of an event occurring, given that another event has already occurred. This is the formula we use for it. Hope you can see the screen. All of you can see the screen wherever you are, right? Hello? Hello, scholars. Can you see the screen?
Yes, we can see the screen.
Good. So the conditional probability of event A, given that event B has occurred, this forward slash, actually, it means given that. That's how we use it. We call it given that. In this concept, we call it given that. So the probability that event A will occur, given that event B has already occurred, is equals to the probability that event A and B divided by the probability of event B. So this is the condition right there. So just like the conditional probability of you getting the job, given that you already have a college degree, is the probability of getting the job and college degree divided by the condition, which is that you already have a college degree and probably experience, depending on what the job requires. Now let us see the application. Look at this question on the screen. It says, test results for marijuana use is presented on the table below. You can see the test results. Does the subject uses marijuana? Um, the results are yes and no. So the answer is yes and no. Then to the question, but the result says it's a positive result and negative results. You can see that positive and yes, positive and no. And it says choose one subject at random. Find these probabilities. Are the subject tested positive, given that he or she uses marijuana? B, the subject actually uses marijuana, given that he or she tested positive. C, the subject tested negative, given that he or she uses marijuana. So let's look at this. So you are given this result. Let us use M for using marijuana. I'm going to move this to the next slide so you can have it. I'm not through. And P for positive, and N for negative. Negative. Okay? Good. Now let's try it. First one says, the subject tested positive, given that he or she actually uses marijuana. So it's conditional. First thing to get the totals of each column and rows, which they have given us already. They give it to us already. We have the totals. Now we can answer. The probability we're looking for is that the subject tested positive, given that he or she actually uses marijuana. This is where we have, yes, the subject uses marijuana right here. This is positive. Now, before I want to put this formula down here so we can be looking at it as we solve this. Okay? Let me bring it down there. That's the formula we'll be using. Right here. I'll place it right here. Yeah, matter of fact, I will place it, yep, right here. That is formula. So, tested positive, given that he uses positive P. Okay, I use marijuana. So let me use P for positive. Okay. Yeah. Positive is P, given that he uses marijuana. M equals. See? So can be, see positive right here, positive results. Everything in this row. Column, see yes. Okay. Yes. Yes. So you can see this intersection. This number represents those that tested positive and they use marijuana, which is 119. So you got to be 119 19 over the probability of B. That means that they use marijuana. So that is the condition B, which is uses marijuana, M. Okay? Or to make it more clear, I can use A for uses marijuana. No, yes, is it pasted? Let me look at the question again. The positive, okay, given that you okay, A for testing positive, so that you don't get confused. B for using marijuana, N for negative. That will not, so that it will not confuse you. Okay. Um. Now, so now we can do it now that way. So, the subject tested positive, P, given that they use this, which is B. Okay. Um. Oh, positive is A. It's my mistake. Positive is A. I'm using A for positive. Tested positive, given that he or she uses marijuana. So A is for positive, B for uses, and then N is for not using marijuana. Okay, good. So the subject tested positive, given that he or she. So this represents tested positive result and use it. 119 out of probability of B, which means they use marijuana. Say yes, which is 122. 122. And that will give us the answer right away. 119 divided by 122. To do that, I'm going to take you to the calculator. Let's see our calculator. Where is it located? Where is our calculator located? Okay. I'm gonna find it up here. So I'm gonna share it with you. Before I do that, let me write this thing down. Okay, before I share, let me write this down. Um, okay. Uh, right, let me put this right here. Okay. Okay, good. That's the calculator right there. So let me write this thing down first. All right. Probability of A given B equals 119 over 122. So we can now go to the calculator and get the answer right away. Okay. We got 119 divided by 122, which is 0.975, 0.975 rounded. Okay. So we're going to go and put it right there. 0.975. Or there's a 97.5% chance that the subject who tested positive uses marijuana. So now, the second one is part B. B says, oh, excuse me, uh, the subject uses marijuana given that he or she tested positive. Each time I ask this, they say, oh, they are the same. No, they are not the same. The condition is different. Here, the condition is that he actually uses marijuana. He or she. Here it is, she tested positive. Now, say tested positive, the subject uses marijuana given that he or she tested positive. Okay. She uses marijuana, yes, then tested positive. So we are looking for the probability that the subject uses marijuana, which is B, given that he or she tested positive, which is A. Okay. That would be this time around, we're gonna be let me show you how the formula will look like. I'm gonna write it down here. Probability of B given A, just a slight change. Since this place will not allow us to put this, I'm going to use this second workbook. Okay. I'm going to insert equation. The probability, subject, um, that the subject um, uses marijuana given that he or she tested positive. B given A, again, it will be, I'm going to make it to be bigger, probably make it 18. Okay. Equal to probability of, or I can call it number of points in B and A and B, because there's still B and A, and the only thing that will change is the condition. Okay, B, but this time around the condition becomes probability of A, since that is the new condition. That's how we're gonna look at like. So a slight different in formula. So I'm going to put it right here so you can see it. So that's gonna be look like. So that's gonna be. You can see it's the same, almost the same as the one that you have at the top, but a little bit different. So having said that, we can now get our answer right there at the side of it. So the probability that the subject actually uses marijuana, given that he or she tested positive, uses, yes, tested positive, which is 119 again. We got 119 divided by probability of A, which is tested positive, which is now 143. 143. Yeah, so we have 119 or 143. So let us do it on the calculator so you can see what the answer will be. So we got 119 divided by 143. Okay. And that gives us 0.832. 0.832. 0.832. So there is about 83.2% chance that the subject who uses marijuana will test positive. And so on and so forth. So that's how you do it. Now, part C, I just try part C at home by, as a practice, see if you can get it right. Any question on this before I move on to the next type of question that you see on conditional probability? Any question on that? So good, excellent, no question. Now let us go to the this type of question. It says two cards are selected in a sequence from the standard deck of the two cards. Find the probability that the second card will be a queen, given that the first card is a king. Assume that the king was not replaced. See, assume that it was not replaced. See, that makes it even a condition. It make it a that's an important statement there. Okay. Now let's use Q for queen and K for king. In this case, because the first card is a king and is not replaced, the remaining deck will now has 51 cards, of which 4 are the queen that we are looking for. So that the probability that the second card is a queen, given that the first card is a king, equals, since it wasn't replaced, so that we still have 4 queen, but 3 kings left and 51 card left, since he said it was not replaced. So that the probability of now become 4 queens out of now 51 cards. And that will give us the answer. Okay. 4 out of 51 cards. 4 divided by 51. Oh, excuse me, sorry. Okay. 4 divided by 51. Okay. I'm gonna go all right, to have 4 divided by 51. But 0.078. 0.078. 0.078. Hello, scholars. Are you still there? Hello, guys. Can you hear me?
Yes, we can hear you.
Good. I hope you me. Any questions so far? I hope no questions. If you have, I'm here. You can ask. Now, before we round up, we'll be looking at how to calculate at least one probabilities, and then we can now round it up with discussion of the Bayes theorem. Okay. So let's see how to calculate the at least one probabilities. You can try this in many examples. It says here, a game is played by drawing 4 cards from an ordinary deck and replacing each card after it is drawn. Find the probability of winning if at least one ace is drawn. Now, this is here we use the complement rule, where we get the opposite of the answer first and subtract it from 1 to get at least 1. Okay? So we say that, let's say that A is at least 1 ace is drawn. So you win when you draw an ace. So at least 1 ace is drawn. Then A complement, no ace is drawn. So of course, you know that there are 52 cards, out of which we have how many aces? 1, 2, 3, 4 aces. So let's see, you get the complement, that means get the opposite of winning, that is losing. then subtract it from 1 to get at least 1. So that means let's start by getting the no ace is drawn. Okay, that is A complement. So the probability that no ace is drawn, probability of no ace is drawn, that means A complement equals, that's no ace is drawn, equals, now, 4 aces, 4 cards, no ace out of these 52 cards. If you remove the aces, the 4 aces, how many cards is left? 48, I believe. When you remove 4 aces, there's no ace. The cards that are not aces are 48 in number if you remove these 4 aces. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So for 8 cards, so no aces. So no, when you draw the card, you draw one, you don't remove 4 at a time. You remove it one after the other. So 48 out of 52 cards. Okay? So you draw those aces were removed 4 times. Raised to the power of 4. Okay, because you're going to be 48 over 52 times 48 over 52 times 48 over 52. Okay? Now, because you say that the game is played by drawing 4 cards from an ordinary deck and replacing it before drawing the next one, raised to the power of 4. So that will give you the probability that there's no aces drawn, which is 48 over 52 raised to the power of 4. We got 48 divided by 52 raised to the power of 4, which is 0.726. 0.726. 0.726. So that the probability of getting at least one ace, which is the probability of A, will be equal to 1 minus the probability of getting no ace, which is A complement. And that will be equal to 1 minus 0.726. 1 minus 0.726. And that will give you the answer. So we have 1 minus 0.726, 1 minus 0.726, get 0.274, 0.274, 274. Or there is 27.4 chance of winning if no eights is drawn. Any question for me? Any query?
No.
No question. Excellent, excellent. Now we can now move on to the next. Now I would say try as many examples as you can on this. Let's go to Bayes' theorem. Now the goal of Bayes' theorem is to help us find out the chance that or the probability that an event will occur, given that given what we already know. So that is the goal here when we're doing Bayes' theorem. And this is the formula we use. The probability of event A happening, A1, given that event B have occurred, is probability of B, given that A1 have occurred, times the probability of A1 over the P of B given A1 times P of A1 plus P of B given A2 times the probability of A2 if there are 2 events involved. If there are 3 events, you continue until you go to the last event. If there are 10 events, you continue. When you see put the event of the first event of interest at the top, you keep going at the bottom. Like here, it says the probability of AI given B, AI occurring given that B have occurred, where AI is the event of interest from a choice of n events. That means I can be 1, 2, 3, 4, 5, 6, 7 events. So it's going to be probability of B given AI times the probability of AI over the P of PB given A1 times the probability of A1 for the first event, probability of B given A2 times the probability of A2 for the second event, and they continue on to the last event, which is probability of B given AN times the probability of AN, where B is an event that has already occurred, and I is the event of interest from a choice of n events. Now, when we solve an example or two, this will make it more clear. Let's look at this equation here. It says here, a book club classifies members as heavy, medium, or light. Light purchasers, heavy, medium, or light purchasers. And the separate mailings are prepared for each of these groups. Overall, 20% of the members are heavy purchasers, 30% are medium, and 50% are light. A member is not classified into a group until 18 months after joining the club, but a test is made. Yep, can see it. A test is made of the feasibility of using the first 3 months purchases to classify members. The following percentages were obtained from existing records of individuals classified as heavy, medium, and light purchasers. You can see them right here for the first 3 months. Heavy, medium, and light. No purchase. 1 purchase. 2 purchases. 3 purchases. So of the heavy, you have 5% did not purchase. For the medium, 15% did not purchase any book. And for the light, 60% did not purchase. For the heavy, 10% purchased 1 book within that 3 months. 30% of the medium purchased 1 book within that 3 months. And then 20% purchased 1 book within that 3 months. So, and so on and so forth. It says, if a member purchases no book in the first 3 months, what is the probability that the member is a light purchaser? Okay. If a member did not buy any book in the first 3 months, what is the probability that the member is a light purchaser? So to solve this, we need to identify our members. So let's say that we use, I'm going to use L for light purchaser. No, let me use N, but no book was purchased. No book was purchased by the member. Then I'm going to use L for light purchasers. Yep. I'm going to use M for medium purchasers. Medium purchasers. Then I'm going to use H for heavy purchasers. Okay. But just can make you. Everybody's coming today. Okay. H for heavy purchasers. Purchasers of the book. Now that we have identified that, we can now be able to answer the question. It says, a member purchases no book. Given that, and a member purchases no book in the first 3 months, what is the if a member purchases no book in the first 3 months, what is the probability that the member is a light purchaser. So we are looking for the what we're looking here is for the we're looking for the probability, oh, excuse me, probability that the member is, matter of fact, let me make this to be bold, make it make this to be 18 font so we can see it clearly. Okay, what is the probability that the member is a light purchaser? We're looking for the P of light purchaser, given that he bought no book, which is N. That's what we're looking for here. So the first thing is to write the formula and then put numbers that will be in the formula and then combine them and you get your answer right that way. Okay. So let me write this down on paper, then we'll go and get the formula from the other workbook. Probability of light purchaser, given that he bought no book. Yeah. So as this section, this workbook will not allow us to put the formula the right way here. I'm gonna get it from here. I'm gonna write it here. We're looking for the probability that is there. Light purchaser, given that he bought no book. Okay. Gonna be, oops. So we have probability of he bought no book. Given that he's a light purchaser. Okay. Times times here. I'm going to use as a way we write times. Use dot to represent times. Okay, right here. I think that's what I need here. Times the probability of light purchaser over the probability that the person bought no book given light purchaser. Okay. Times probability of light purchaser. Plus, now you do the same thing for the all types of purchasers we have there. All of them. Remember, we have the heavy and medium. So what you just did for light, you did for the medium and heavy. So we have the probability for no book was purchased, for given that is a medium. Oh, excuse me, sorry. This thing is for given that is a medium purchaser. No book was purchased, given that is a medium purchaser. Times just to have it, yeah, times the probability of medium purchaser plus the probability of that no book was purchased given the heavy purchaser. No book given heavy purchaser. Oh, it's going to mess us up again. Heavy purchaser, right? No book was purchased given heavy purchaser times the probability of heavy purchaser. That's right. Heavy purchaser. So I'm gonna adjust this, make it 16 so that it will accommodate this place. Yep. So this is the formula, right? I'm gonna make it bold. I'm gonna copy it and paste it into our main workbook, and then we can solve this question right here. Solve it right here. I'm gonna paste it right here. At the formula right there. So now, which means that we need to get all these individual parts. No book given light times probability of light. No book given medium times the probability of medium, and no book given heavy times probability of heavy. So that we have the probability of heavy purchase will be, according to what you have in the table, heavy is given on the, say overall 20% of the members are heavy purchasers, 30 are medium, and 50 are light. So for heavy, you have 20%, which is 0.2. For the probability that they are medium purchasers, It says here that is 30%, 0.3. And for light purchasers, light is equals, it says it is 0.5 at 50%. 0 point. Now, the probability of heavy, I'm going to put it right there. Probability of heavy, this one, no book was purchased giving light. No book was purchased giving light is a light purchaser. Maybe, see, go to the table. Zero book giving light is 60%, which is 0.60. Now for the medium, okay, let me start from heavy. Sorry, let me do it for heavy first, since I have heavy here first of all. No book was purchased, given that it's a heavy purchaser is 5%, which is 0.05. No book was purchased, given that it is medium. No book given heavy. Mistake. No book given medium. No book given medium will be, according to the table, zero book given medium is 15%. 15%, which is 0.15. Then no book was purchased giving light. No book given light equals, according to the table, is 60%. So you have everything you need. All you have to do now is to plug them into this formula. I'm going to write this down. We go to the other workbook so we can plug them in and I'll get our answer. Probability of heavy equals 0.20. Probability of medium equals 0.30. Probability of light equals 0.50. Probability of no book given heavy equals 0.05. Probability of no book given medium is 0.015. And then probability of no book given light is 0.60. So let me write the formula down, and then we go to that workbook and then put all these numbers in, and then we can now go from there to get the answer. Okay, so you can see that after this, you can see that it is really easy. Just put the correct information, put the numbers at the right part of the formula. Okay, right, then you get the answer. Okay, probability of no book given light and probability of light. Now, let's go and put all these things into that formula and then get our answer. So we're gonna go and put it right here. So here we're gonna have 0 point, no, you see, no book given light is 0 point times, okay, times probability of light purchase, which is 0.50. Something like here, no book given light. Okay, we're gonna have 0.60, okay, times 0.50. Okay, plus here we got so you have no book given medium. We have it as 0.15 times the probability of medium, which is 0.30, plus next would be heavy. Probability of let me make sure I have everything right. Light, okay. The next one is heavy. I have heavy here, not right. Heavy. Heavy. So we have given heavy, I have it 0.05 times probability of heavy, which is 0.20. So let me just, and that will give us the answer. Let me just double check it again. 0 given light, which is 0.05 times probability of light, which is 0.50. And that's repeated here. 0 given medium, 0.15 times the probability of medium, okay? Heavy, given no purchase, 0.05 times probability of heavy. So let us put this, let me write this down so you can now have it. I'll calculate 0.60 times 0.50 over 0.60 times 0.50 plus 0.15 times 0.30 plus 0.05 times 0.20. So let us go and put this in the calculator and we'll get our answer right away. So we have 0.60, excuse me, times 0.50 over 0.60 times 0.50 plus 0.15 times 0.30, okay, plus 0.05 times 0.20. 0.845, I mean, 0.845, okay? 0.845. So answer become 0.845. I'm gonna make it unbold it. Okay, so I'm gonna copy this and paste it to our main workbook. That's the answer we're looking for. So any question on this? Any question, guys? Excellent. So no question. So now, since there's no question, we can now move on to the next one. Now, I can ask you this question in a different form, and it's still the same principle. Okay? Look at this one. It says, three factories, factory X, Y, Z, manufacture identical light bulbs, and their products are mixed together in a warehouse. Factory AX produces 30% of the bulbs, factory Y produces 45%, and factory Z the remainder. Of the bulbs made by factory X, 2% are defective. Of those from factory Y, 3% are defective. And of those from factory Z, 5% are defective. If a bulb is selected at random from the warehouse, if a bulb selected at random from the warehouse is defective, what is the probability that it was produced by factory Z? Again, what you're going to do is this. Okay, solution. It told us that make this to be 18. So they told us that factory C produces 30% of the bulbs. Okay, so that let us use so we have the probability that factory C, the bulb is from factory C, producing bulb from the X equals 30%, which is 0.3. From factor B, factor Y, probability P of X, excuse me, P of Y, okay, is 45%, which is 0.45. Then the rest are produced by factor Z. Probability of factor Z will be 100 minus 45, 45. So I'll get it from here. Gonna be 100% minus 30% minus 45% is 25%. So it produces 25%, but it produces remaining, which is 25%, which is 0.25. Okay? See, now the question was, if a bulb is selected, we're not done yet, actually, because it also says that of the bulb manufactured by factory C, 20% are defective. Let us use D for defective bulb. Let us use D for defective bulb. Okay. So we say that 2% of the bulb made by factory X, 2% are defective. So probability of defective, given that it is from factory X, equals 2%, which is 0.02. Of those from factories Y, 3% are defective. So that the probability of defective, given that it's from factory Y, equals, it says 3%, which is 0.03. Okay. And it says, and those from factor Z, 5% are defective. From factor Z, you have defective given factor Z equals 5%, which is 0.05. Now we can now put this all together in the formula. The formula will now become, let me write the formula down. Because the question says, if a bulb is selected at random from the warehouse, is defective, what is the probability that it's produced by factory Z? Okay. So what is the probability that it's produced by factory Z? So we're looking for the probability that it was produced by factory Z, given that it is defective. Okay, that's what we're looking for. What is the probability that it's from factory Z, given that it is defective? That's what I'm looking for now. So I'm going to write probability of defective. Let me get another space here. Probability of defective, okay, sorry, that it is from factory Z, given that it's defective. So let's look at how the formula will look like. I can write it here. Factory Z, given that it is defective. So you're gonna be, okay, I'll move this one here. Probability of D given defective, given factor z, oh, excuse me, given factor z, defective, given factor z times, what is the multiplication sign? I always say again, times the probability of factor z. Now, here, you repeat the same thing, but you gotta repeat it according to the order. S, Y, Z, but S come first, Z come last. So you gotta use here probability of defective, given that it is factor X times the probability of factor X. So you keep going like that for factor XY. Okay. Probability of defective given factor Y times probability of factor Y. This one is the probability of, that's the, now you can add your Z. Probability of defective given factor Z. Okay. Times probability of factor Z. Now you can do, actually it can be in if we put it in any order, if you start with factor Z, like talk about the denominator. Now the numerator must be defective given factor Z times probability of factor Z. But here you can, write this one first before the other one, but it's better to go according to the order. So that's the formula we need. I'm gonna copy it and paste it here. Okay. Paste it in the memo book. So now we can now start putting the numbers. So let me write the numbers down and we can go and put them in. First of all, let me write the formula. Probability of defective given factor Z times probability of factor Z over probability of defective given factor X and probability of factor X plus defective given factor Y times pure factor Y plus defective given factor Z times pure factor Z. So let us write this down. I'm going to write all these numbers out. Pure factor X equals 0.30. Pure factor Y equals 0.45. Pure factor Z 0.25. Pure defective given factor X is, you can see right here. Make sure you're seeing this. Yep, you're seeing it. Factor X is 0.02. Probability of defective given factor Y was 0.03. Pure of defective given factor Z was 0.05. So let's go and plug this in and then we can get our answer. Okay. Go there and plug this now. So this place will be 4. Okay. I got 0. Given Z, which is 0.05 times, I even have to put it in times, the times table. Okay, times, I'm going to use regular multiplication symbol so it won't confuse you. Times root of Z, and Z is 0.25 over, got this one, the given x for x. For x, we have 0.30 times, sorry, not 3, not 0.30. Root of d given x 0.02 times the probability of x times the probability of x for x. We have 0.30 plus this one we have defective given factor y. We got it as 0.03 times the probability that it's a factor y, which is was produced by factor y 0.45 plus this one. Have that is produced by factor z. D given z is 0.05 times the probability of factor z 0.25. And that will give us the answer. So I'm going to write this down. I've run out of spaces here. So let me write it on this stuff. Let me write it here. Okay. I'll write it here. Probability of z, given that is from factor that is factor z, given that is the defective will be 0.05 times 0.25 over 0.02 times 0.30 plus 0.03 times 0.45 plus 0.05 times 0.25. That gives us the answer right away. So let's go and get the answer from the calculator, and then we round up. So we got 0.05 times 0.25 over 0.02 times 0.30 plus 0.03 times 0.45 plus 0.05 times 0.25. 0.391, 0.391, 0.391. So we'll have it right here, 0.391. Rounded. 0.391. So I'm going to copy this and paste it into our main workbook. Okay, here. Questions on this? Any question? Excellent. No question. Good. Now, let us round up. You can try the rest of this as a practice, as a practice. Now, I'm going to show you what your classwork will be by going to your classroom. I'll share this first. With your classroom. Where's your classroom? Open it. Okay. Let me share it. Your classwork, this is classwork 5B, review on counting rule and on computing bias theorem. This classwork have two sections. First section is to answer this question, part one, which is similar to the last one I solved. Second one is to watch this video on counting rules. Then choose one question there, write it down on paper, and then follow the directions here. When you finish, this one will be solved on paper, handwritten, black pen or pencil, no blue pen. If you put blue pen, it will get it 0. No red pen, no green pen, just black pen or pencil. Hello, can you hear me, guys? Hello?
Yeah.
Black pen or pencil, and it must be handwritten. I'm not accepting typed, anything typed. It must be solved with a hand. Black pen or pencil, solve it, then go to part 2, watch the video, choose one question that I solved there on counting rule, solve one of them, following this story. Then when you finish, take a photo of it and upload. Remember, no blue pen, no red pen, no green pen. No need, and I don't want anything colored there. It must be pencil or black pen, and it must be handwritten. Now, I will see you guys next week. And any question before we leave?
Yeah,
you
Professor, I got a
Oh,
Professor, I got a question.
Yes, sir.
Yeah, so can you repeat everything like because you said classwork B, so you said watch the video, then what else did you say?
Everything I said that is I wrote them down here on the assignments. Like what I'm saying.
Oh,
Yeah, you see
okay.
already. Yeah, you see already. I wrote it
So
here.
all the instructions are in there?
Yes. No typing, no blue pen, no red pen, no yellow pen, only pencil or black pen, and that we use to do this assignment. This is classwork. And it's hard to be right handwritten. The first part is to solve this question, which is the same thing as one I just solved last. Second one is to watch this video, choose any question there, write the question out, follow the direction I give you to solve it, and then take a photo of it or scan it and then upload. And it's due tomorrow. All right, any other question?
Okay, that's
have
cool.
you classwork? Have you graded classwork 4?
No, I'm still which one is classes for? Let me see.
It's the practice work on empirical rule.
No. I'll take care of that
Okay.
this weekend. Yeah.
Okay.
Yeah. All right, guys. See you next week.
Wait,
Did
I
you
had
take
a
attendance,
question
sir?
Have
before
a
I
question?
before I went. So I emailed you about the pivot table assignment that I needed help with it, and I was wondering like, one, could you help me with it? Because I like submitted it, but I didn't do it the correct way that was supposed to be done. But that's because I needed help with it, and I put in the comment section that I needed help, and then like, you just yeah.
Yeah, so unfortunately, I cannot help you with assignment. I can't give you an assignment and help you with it. So it's you that will do it by yourself, either by watching the video that
Because
I
I had technical difficulties with Excel, like the way you wanted us to like copy and paste a formula, I couldn't do it with my computer. So I was trying to figure out like how could
Were
I?
you in the class? If you're in the class, you ask me, I can use something different to show you how to copy and you don't have to copy and paste it. You upload it. You upload an Excel file. So if you want to make it up, what the only thing I can say is maintain your attendance in good. Any attendance that is that is less than 70% is not eligible for makeup. But if your attendance is 70% and above, next month when I will start reviewing my grade, you can request to make it up, and I will grant it so long as your attendance is good. I'll give you something else to make it up. But I don't help with assignments, but I can solve something. I can solve something that is similar to that. If you ask me in the classroom, then you can use it as a guide. Any other question?
Yeah, did you take attendance?
Yes, I still have it on paper.
Okay.
All right, guys. See you guys next week.
Wait, did you get me?
What's your name?
Jersey Johnson.
I don't even have any Johnson on this paper. But I wrote it down with my pen. So I now that you said it, let me just check it out. Yeah, I got you now.
Okay, thank you.
You're welcome. So next time if you're not on paper, just write your name. Okay.
Okay.
All right, guys. See you next week. Twice. Okay.